Hi, this screencast is on conservation of mass. Um, Before we start that, there are 5 questions I'd like to have a go. So pause the video and have a go. Okay, so question 1, what does the word conservation mean? Um, nothing's lost, nothing's gained. Whatever you started off with, you end up with the same mass, you're conserving it. Um, I'm not sure where else in science have you seen the word conservation. There'll be many places there. Number 3, what do you think the conservation of mass is? We've already talked about that. So whatever you start off with in a chemical reaction, whatever the mass is, the products should have the same mass. Number 4, what are the 3 subatomic particles? That's protons, neutrons, and electrons. And which subatomic particle is the lightest? That is the electron. Moving on. So we're going to take a look at conservation of energy, and there's your learning objective. There will be, if you was doing this in a classroom, we would be using models. Obviously, we're not in a classroom, so we're going to try and skip that. Define the concept of conservation of mass and apply your knowledge of conservation of mass to chemical reactions. So you can pause the video and you can think about the word conservation yourself and see what you come up with. Okay, moving on. Here's some keywords. Have a look at the definition. Conservation of mass. So you're not destroying anything, you're not losing anything, and you're not making any new mass. Molecule, formed when 2 or more atoms chemically join together, bond together. Compound, formed when 2 or more different atoms join together. Now, this could be something like water. So you've got water, you've got carbon dioxide, but they have to be different atoms. Elements, it's a substance that is made up of one type of atom. It's a pure substance. Reactants, it's a substance that is changed in a chemical reaction. So it's something completely new. And the products, a substance that is created when a chemical reaction has taken place. Moving on. Conservation of mass. If you look at, this is the reactants, and that's the product. If you count the number of atoms, you can count 16 atoms in here, and if you look at the product, there will also be 16 atoms. So conservation of mass, no atoms are lost or made during a chemical reaction. The mass of the products is always equal to the mass of the reactants. Remember that. Here's an investigation you might sort of do. You've got a conical flask with some acid inside, hydrochloric acid. The magnesium is here. You put the magnesium into the conical flask, a chemical reaction takes place, and the products are in here. However, one of the products is a gas. You can see the bubbles, and that gas will escape, which means the reading, which should be 180 points, same as this, will not be, because some of the product is escaping, the hydrogen gas. Moving on. What elements are in carbon dioxide? Carbon and oxygen. How many? Well, you can see there's 1 carbon and there's 2 oxygen atoms. Now this is where we're not going to use molymod, so I'm going to move on from here. Balancing equations, obviously here we go. I'm going to try and balance these equations because according to the conservation of mass, the number of atoms on this side must always equal the number of atoms on this side. So the equations must be balanced. So pause the video here and see if you can balance these 5 equations. Okay, so what you should have got, there you go, the first one, second one, third one, fourth one, and fifth one. And if you look at it, the number of atoms on each side, this side will balance the number of atoms that side, and so on with all of them. Okay, and that's the lesson finished.